step x equals to a. Now we are going to see the solution for step x equal to a equation. So as already we have discussed about what is going to be greatest integral value of x, and now we are supposed to see about what is going to be the solution for such kind of equation. So for which we will go with some example. Say for example, if I have got say step x is equals to 5. So what are the values of x which are going to satisfy this equation? So for which I'll go ahead with the number line. Let me take the number 5 on it. As already know that 5, the step of 5 value is going to be equals to 5. So 5 is going to satisfy the equation, and apart from 5, what are the numbers which are going to satisfy this equation? So if I go with 5.1, 5.2, 5.3 or any number like 5.9, step of 5.9 is going to give you equal to 5. Therefore, the values of all the numbers below 6 are going to satisfy the equation. And does all the values of x below 6 will satisfy? Like for example 4.5, does 4.5 also will satisfy the equation? Means obviously no, because step of 4.5 is going to be 4, so it will not satisfy the equation. So the what are the values are going to satisfy the equation means obviously all the numbers right from 5 to numbers all below 6. So all the numbers from 5 to below 6 are going to give you a solution. That means you can say that the answer for the solution is going to be x value lies between 5 and 6. As already we have seen as per the definition, the value of x takes from numbers between 5 and 6. So the solution for such kind of equation is a less than or equal to x less than a plus 1. So here a is going to be 5. So the values of x according to satisfy equation is going to be 5 less than or equal to x less than 5 plus 1 is going to be 6. So any number between 5 and 6 including 5 is going to satisfy this in equation. So coming for the next property of absolute value of a value of a variable x. So here let me go with the absolute value in equation of less than type. Say for example, I have got an equation of absolute type where step x is going to be less than I. Here I is going to indicate as an integer, where I is an integer. Let's say about what is going to satisfy this kind of inequation. So for example, say I have got step x less than 5. Let me go with what are the values of x which are going to satisfy this inequation. Here I have taken the integer on the right side. So the example for it is step x less than 5. So let us see about what numbers are going to satisfy this inequation. So let me just take number 1 below 5 and 1 above 5. That's going to be 4 and 6. Now let us check what kind of numbers are going to satisfy this inequation. So here if you observe carefully, if I take any value 5 or above 5, say 5, if I take step of 5 is going to be 5, 5 cannot be less than 5. Or if I take any number more than 5, say 5.1, 5.2, say if I take 5.2, step of 5.2 is 5, which is also not less than 5. So all the numbers above 5 including 5 are not satisfied in this inequation. So what numbers are going to satisfy an equation? Let us take some number less than 5, say 4.9. If I take 4.9, step of 4.9 is going to be 4 and 4 is less than 5. So any number less than 5 is going to satisfy the inequation. So the solution for this inequation is going to be x less than 5. So what are the number you take less than 5 are going to satisfy this inequation. So a general property can be written here based upon the example. So step of x less than an integer, it means that x value would be less than I. So this is what the y property we have. And coming for the next property, say step x less than or equals to I. So if I take say inequation step x less than or equal to I, so what is going to be the solution for this inequation? Let us check the solution for this inequation. That means let me take some number, some inequation, say x step x less than or equal to 4. So what is the value of x which is going to satisfy this inequation? For which I will go with the number line, like how I have done the previous example. So in this example, I take a number line with a number 4 and also one number below 4 and one number above 4. That means I'll take the integers 1 less than 4 and 1 more than 4. Now let me start taking the numbers right from 4 onwards. If I take 4, the 4 is going to satisfy this inequation because step of 4 is going to be 4 and 4 is less than or equal to 4. And if I take any number up to 4.9 also, the step of 4.9 is also equals to 4. So 4 would be less than or equal to 4. Whereas if I take 5, 5 will not satisfy this inequation because step of 5 is 5. 5 cannot be less than 4. So any number less than 5, any number less than 5 are going to satisfy this inequation. So even you take a number less than 4, that is 3 if I take, or 3.5, step of 3 or 3.5 will give you a number which is less than or equals to 4. So finally, so what are the values of satisfying equation means? Obviously, if x is a number which is less than 5, strictly less than 5. Of course, 5 do not satisfy an equation because step of 5 is going to be 5. 5 cannot be less than 4. So any number less than 5, say 4.9, if I take step of 4.9 is 4, 4 is less than or equal to 4. So what's the answer we got is, we have got the value of x which is less than 5. So if I take this as an integer I, then the solution is going to be x less than I plus 1. There is 1 more than the integer. So the solution for this inequation is going to be x less than I plus 1. So now onwards, if I ask you about any inequation of this type, say step x less than or equal to 2, the solution for it is going to be x less than 1 more than this integer, that's going to be x less than 3. If I ask you step x less than or equal to minus 5, the solution for it is going to be x less than 1 more than this integer. So 1 more than this integer means going to be minus 4. So simply apply this property and you are going to get the result for the inequation. So far we have seen about less than type and less than or equal to type. Now we will check about how to get the greater than type and greater than equal to type inequation solution for it. So I go with step x greater than an integer I. So for which I can also explain you through the example. Let me go to some example where I take an inequation greatest integral value of x, inequation involving the greatest integral value of x. Let me take step x greater than or equal to say 4. So let's suppose that we take some step, okay, I want strictly greater than, so I will go with step x strictly greater than 4. So what are the values of x which are going to satisfy this inequation? Again, exactly same way, draw a number line containing the integer 4 and also one integer above it and one integer below it. So now let's start putting the numbers right from the number 4. If I substitute 4 into it, step of 4 is going to be 4, but 4 cannot be greater than 4. So the number 4 cannot satisfy the inequation. If I take some number above 4, say 4.1 or 4.2, even the step of 4.1, 4.2 are going to give you 4, that cannot be greater than 4. So the values of x which are going to satisfy the equation are going to be from 5 onwards. If I substitute 5, because 4.9, even 4.9 will not satisfy the inequation because step of 4.9 is 4, which cannot be greater than 4. So only number starts from is going to be 5. If I take step for 5, step of 5 is going to be 5, so 5 is going to be greater than 4. So any number 5 or more than 5 is going to satisfy the inequation. Say 5.1, 5.2, whatever it may be I take. If I take 5.3, I get step of 5.3 is going to be 5, which is going to be greater than 4. So the value of x which satisfies this inequation is going to be x greater than or equals to 5. That means the number 5 or more than 5 is going to satisfy the inequation. So in this case, if I want to write a general property here, say step x greater than I, where I is the integer, so the solution for such kind of inequation is x greater than or equal to 1 more than this integer. That means the solution for this inequation is going to be x greater than or equals to I plus 1. So based upon this property, I can get the solution for the greatest integral value of x inequation. So if by using property here I can say, if I ask you step x greater than or equals to greater than about 1, the solution is going to be x greater than or equals to 1 more than this integer, this is going to be 2. If I ask you about the solution for step x greater than or equals to greater than say 3, the solution for it is going to be x greater than or equal to 1 more than this integer, is going to be 4. If I take step x greater than minus 2, it is going to be x greater than or equals to 1 number more than this integer. 1 number more than this integer is going to be minus 1. So in this way, by using this property, we can solve the greatest integral value of x inequations. So this was the important properties, and we have got one more important property that is going to be seventh one is going to be step x greater than or equal to I. What happens in the case if I get step x greater than or equal to I? Let me go with some example again. If I take step x greater than or equal to 4, so what is going to be the solution for such kind of an equation? So what we do is we draw the number line again. So we'll mark the number 4 and also mark number 3 and number 5. One integer above 4, one integer less than 4. Now when I substitute 4 into it, the 4 is going to satisfy the equation because step of 4 is going to be 4. 4 is greater than or equal to 4. So 4 is going to satisfy the equation. So because 4 is going to satisfy an equation, any number more than 4 is 4.1, 4.2, 4.9, any number is also going to give you the same result, because if I take say 4.5, I get step of 4.5 is 4, which is also greater than or equal to 4. So any number more than 4 including 4 is going to satisfy the equation. What about the numbers less than 4? Less than 4, if I take some number say 3.9. If I take 3.9, step of 3.9 is going to be 3. 3 cannot be greater than or equal to 4. So the numbers less than 4 are not going to satisfy the equation. So what values are going to satisfy the equation? Obviously any number starting from 4 onwards, any number greater than 4 is going to satisfy the equation. A solution for this inequation is going to be x greater than or equal to I. So the integer, if it is greater than or equals to 4, that is here the integer whatever is there, it is going to remain the same. So whenever you have got the inequation of this type greater than or equal to type, then the solution is going to be the same integer. Means here we get step of x is greater than or equal to I, means it's nothing but x value is going to be greater than or equals to I. So based upon these properties, you can do the problems. Say for example, if I ask you step of x greater than or equal to minus 2, it is going to be given nothing but, so it is going to be x greater than or equals to minus 2. So it remains the same thing. So without the bracket. So by using these properties, we can solve the greatest integral value of x in equations of either less than type or greater than type. This aim contains the problem of this kind, so we can make use of these properties and get the results. Let's do some example sums from the aim. Say they ask you about solution. Say they asked you some questions. Say he asked to evaluate step x less than minus 2, and second one he asked you to evaluate step x greater than minus 3, and third one they asked you to evaluate step x less than or equals to 5, and lastly he asked you to simplify or evaluate the value of step x greater than or equals to minus 1. So by making use of these properties what we have learned earlier, we can solve these inequations. So we can either draw with the number line and get the result, or otherwise use the properties. If I take the first example, question number A, it's going to be in the form of step x less than I, where I is going to be integer. The solution for it is going to be x less than the integer. That means the solution for it is going to be x less than minus 2. So based upon the first property here, and coming for the second one is going to be in the form of this property number 6, that is step x greater than an integer. Step x greater than an integer is going to have a solution x greater than or equal to I plus 1. That means the solution is going to be x greater than I plus 1. That means going to be x greater than minus 2. So the solution for step x greater than minus 3 is going to be that. And coming for the third one is going to be step x less than or equal to 5. So step x less than or equal to 5 is of fifth type. So step x less than or equal to 5 implies x is less than I plus 1. So we get the result here as x is less than 5 plus 1. So it means nothing but x is less than 6. Coming for the final thing, that is step x greater than or equal to minus 1. Step x greater than or equal to minus 1. Here it's integer, so therefore we can apply the property x is greater than or equals to I. That means x is greater than or equals to minus 1. So in this way, by making use of the properties of the step function, we can go ahead with the solving this kind of inequations. And coming for the other property, important property, what we have is the domain, of course, and step of x plus y. Yeah, step of x plus y is the next other property. What we have is going to be very important property. So if I have got two integers, say eighth property, if I take it, step of x plus y is always greater than or equal to step x plus step y. This can be done through some example. Say take some number, say x as say 3 and y as say 2. So if I go with say 3.1 plus 2.9 or 2.9 or say 2.8. So if I have taken x value as say 3.1 and y value as 2.8, then I will take the LHS here. The LHS is going to be the x plus y value. So I have got x plus y, step of x plus y is nothing but we got it as step of 3.1 plus 2.8 gives you 5.9, which is equal to 5. And coming for the RHS we have step of x plus step of y. So step of x is going to be 3.1 and step of y is going to be step of 2.8, which is equal to 3 plus 2 is also equal to 5. So that means what we have verified is we have verified that step of x plus y became equal to step of x plus step of y. So it should be either greater or it should be equal. So in this case, we got the result as equal. If in case if I take the second number as say negative number, say if I take a second number as minus 2.8, so what's going to be the answer? If I take step of minus 2.8, so 3.1 minus 2.8 gives us the value as say I'll take it as minus 2.1 as better. So step of 3.1 plus minus 2.1 gives you 1. So step of 1 is going to be 1. Exactly same way here, if I take step of 3.1 plus step of minus 2.1, I get the result as step of 3.1 is going to be 3 and step of minus 2.1 is going to be minus 3. So obviously it's going to be 0. So what you observe here is we observe that step of x plus y is greater than step of x plus step of y. So finally we can conclude that step of x plus y is always greater than or equal to step x plus step y. So here we have seen about what is the greatest integral value of the variable x, and now we will see about the greatest integer function. Let's see about the greatest integer function. What is the greatest integer function? So as because we came to know about what is the greatest integral value of x, we can say about what is going to be greatest integral function. So it is greatest integer function. Written as GIF, greatest integer function. So a function of the form y equals to step x is said to be a greatest integer function. So here a function which is involving the step of the variable, such kind of function is always called as a greatest integer function. So a simple example is step x, that is a function of the form y equal to step of x is going to be called as a greatest integer function. And for this particular example, what is going to be the domain of function? So that means we need to understand about for what values of x this is defined. As you know, it is step of the variable, so it's going to give you integer obviously. So whatever real number you take, the step value will exist. So it is defined for all the real numbers. So x can take any real number, therefore the domain of the function is going to be the set of real numbers. What about the range? Range of the step function here for this particular function step x, what is going to be the range? The range of this step function is going to be whatever number you substitute here, the result is going to be an integer. So whatever real number you take, the result is going to be integer. Therefore obviously the range of this function f is going to be z, that is set of integers. So this is all about the properties of the greatest integer function, the properties of greatest integral value of x, and also the greatest integer function. Now let us see about the next type of function called as least integer function. So before going to the least integer function, we need to know about least integer value of a real number x. So the least integer value of a real number x. So the least integer value of x is denoted by bracket x, that is going to be read as least integer value of x. So as before going to the least integer function, we need to know the properties and definition of the least integer value of a real number. So let us see about what is the least integer value of the real number. So the least integer value of a real number x is the least integer greater than or equals to the given number. That is, if n is less than x is less than or equal to n plus 1, then the least integral value of x is equals to n plus 1. So the definition of the least integral value of x is explained clearly through an example. Let us go ahead with some example. The least integral value of say 3.5. Let us try to find out what is the least integral value of 3.5. It is quite similar to the greatest integral value of x, but not exactly the same thing. So we know that 3.5 lies between the two integers 3 and 4. So 3.5 lies between 3 and 4, and 3.5, the least integral value of 3.5 is nothing but the least integer greater than or equals to the given number. So how many integers you will have greater than the given number? Greater than the given number, you will have many integers, 5, 6, 7 and so on. So greater than 3.5 will have many integers. Among all those integers, what is the least integer which is greater than 3.5? The least integer greater than 3.5 is 4. So the least integral value of 3.5 is going to be equal to 4. So the least integral value of 3.5 is the least integer greater than or equal to the given number. So 3.5 is going to be 4. So always the least integral value of number will always write to the right side of the number on the number line. So as the greatest integral value lies towards the left side, the least integral value lies towards the right side of the number. Say if I ask you, what is the least integral value of say 2.3? Least integral value of 2.3, because